Hello, everyone. Thank you for coming for today's workshop. In this workshop, we'll be going over geometry contest concepts, and we're going to link that to AI by seeing how AI sees the world, because how AI sees our visuals, pixels, images is all related to geometry and spacing. So that's what we're going to be looking at today.
Okay, first we'll be introducing our team. So Varun, do you want to go first?
Yeah, so I'm Varun. I've been helping out running this workshop, and yeah.
I'm Ritu, and I'm a high schooler as well. So our group is mainly focused on high schoolers teaching high schoolers. So that's why we're focusing on like contest math and AI. Okay, Zoya,
Hi, I'm Zoya. I'm also a high schooler in ninth grade.
we have one more team member, but he wasn't able to make it today. But if you keep coming to the workshops, you'll be able to see the rest of us teach as well. Okay, Varun, do you want to get started on explaining the slides?
Yeah. No worries. So in geometry, one of the most important things we need to talk about are angles because a lot of times you're going to be getting working with just two-dimensional figures. So here are some key relationships that it's important to know. So complementary angles, that just means two angles that will sum up to 90 degrees. So you can imagine like a right angle triangle like this. And then if you split this in half and you said this was a number, you'd be able to find that number using that relationship. Supplementary is supplementary angles are when two angles add up to 180 degrees. So if you had a straight line and this would equal to 180, you could use math to um, substitute and find that angle. Vertical angles equal to when lines intersect. Corresponding angles are when you have parallel lines and they're equal. So like the Z angles, if you guys are familiar with those type of angles. Same with alternate interior angles, co-interior, and so these ones are just related to when you have parallel lines and you have parallel lines and you have intersections. Using that, you can say you can have properties like this angle plus this angle would equal up to 180, etc. And that only works if this is parallel to that line. So an angle chasing is an important strategy in contest math because a lot of times you're going to be able to find a side or find something. So by using angle chasing, you would be able to find everything you would need, and hopefully using that, you would be able to find a side, or if the question said to solve an angle, that would be sufficient enough too. Okay.
Okay, now we have a problem in the bottom that basically goes over these topics. So we'll be giving you guys a few minutes to try to solve it. And then we'll be going over the solution. So take about like 2 minutes to try it out. And you can share your answers in the chat once you're done. Okay, has anyone solved it? If you want, just share the answer in the chat or come on mute and just share it. If not, I'll be going over the problem right now. Okay, so the question asks when there's two parallel lines cut by a transversal, so basically what we have drawn on the left, one angle measures 3x plus 15 and its alternate interior angle measures 5x minus 25. So first, let's draw the transversal and the parallel lines. So it'll look like this, and then one angle. So let's say this angle be 3x plus 15. And like we said before, its alternative angle would be 5x minus 25. And because they're alternative interior angles, they'd be equal to each other. So we set up this equation and then we can just solve from here. So to subtract 3x, 2x equals 40, 20 equals x. So that's how we get x. And then if we plug it back in, we would get that both of the degrees are 75. And then like Varun mentioned before, supplementary angles add up to 180. So this right here would be a supplementary, just like over here on top. So what we need to find is this angle, the measure of the larger of the two co-interior angles. So the larger out of this one versus that one. So from 180, we can subtract 75 and get 105, which would be our answer. 105 degrees. Does that make sense? If you guys just want to type yes in the chat if it does. Okay, well, I'll be moving on to the next slide. Okay, moving on to triangles. So building on top of angles, triangles are often used alongside angles. So first, let's start off with the triangle inequality. When we learn triangles, we start off by getting the three side lengths. So from there, we know that one side length must be less than the sum of the other two. For example, a triangle that had the side lengths 3, 4, and 5, 3 plus 4 would have to be greater than 5, the largest side. And then back to angles. To find proportions in triangles, we look for similar triangles. And we can find this out by comparing their angles and sides. So AA similarity would be whether the two angles are the same. SAS would be side angle side. So we'd look for two sides that are proportional to each other, and then an angle between that. That's the same. And then side, 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 if all the sides are proportional, then it would be a similar triangle. So this is why we always look for parallel lines and shared angles in our triangle. Moving on to polygons, the sum of the interior angles of an n-gon would be n minus 2 times 180. So for example, let's just go back to triangles. Triangles would have three sides, so that would be like a 3-gon. 3 would be our n, and then 3 minus 2 is 1, times 180 would just give us 180. And that's why triangles have a sum of interior angles worth 180. And then we can divide that by the number of sides to just get each of the angles, so 60, 60, and 60. And then special right triangles are 30, 60, 90, and 45, 45, 90. So these are to do with their angles, and then we get proportions for their sides. So think about it like this. So if we get a triangle here, and that's our 90 degrees, we can put x next to them. So if it was a 45, 45, 90, then this would be x, this would be 1x, and this would be x root 2. That's drawn kind of badly, sorry. Root 2. And so it would just be the same for the 30, 60, 90, where the x goes to the 30, 2x would be for the 90, and then x root 3 would be for the 60. Okay. So now we're going to try this problem. It's a little complicated, but it still uses a lot of the things that we were just reviewing over there on the previous slides. So let's read the question first. In triangle ABC, point D divides, oh, I think that's written wrong. Divides AC, so it would be here, AC, so that AD and DC have the proportion 1 and 2. So that's their proportion. Let E be the midpoint of BD. So here is the midpoint, so we can label that by showing how the sides would be equal to each other. And let F be the intersection of line BC and line AE. That's what we have right here. Given that the area of the triangle ABC is 360, what is the area of EBF? This triangle here. So starting off, what we're told is that AD and DC have a ratio of 1 to 2. So from there, we can see that AD and then AC over here would have a ratio of 1 to 3, which would let us know that triangle ABC and we already know that the area is 360, and then dividing that by 3, because if this is 1 to 3, it would just be a ratio for this, and then we could divide it by 3 to get 120. Does that make sense? So the area of this triangle right here would be 120. Similarly, for the midpoint here, we get told BE and then BD have a ratio of 1 to 2 because E is the midpoint. So we know that triangle ABE is what we're looking for, and then we can get that from ABD divided by 2. Be 120 divided by 2, which would give us 60. So this triangle right here would have an area of 60. Then this is where it gets a little more complicated, but we look at the altitude. So AF is what we're looking at. And then that's the altitude from BC to A from here. And then to get a proportion from there, we look at this side, so AC and AD. And from there, we can see how, because of the ratios of 1 to 2 and 1 to 3, BC to E here would be half of the height from BC to D. So we think here. And it's all based on the ratios of this being 1/3 and this being 1/2, like we've shown here. So height A would be the altitude, and then height E from BC to E would be half of height D. So, well, so D originally would be 2/3 H of A because of the proportions here. And then half of that would give us 2/6 or just 1/3 HA. So here's where it gets a little confusing, but we basically have to just look at the ratios and change the lengths based on that. So we get 1/3 HA. And from there, that's how we get the triangles. So EBF, I'm going to be erasing this. Space, okay. EBF over ABF, the triangles, equal EBF over EBF plus ABE. So let's look on the graph. EBF plus ABE, ABF, sorry. This, so it's just proportions again, would equal EBF plus EBF plus ABE. So it's just adding them. And then we can plug in 60 for ABE because that's what we found as the area, which would just give us EBF over EBF plus 60. And we already know EBF over ABF would be 1/3 because of how we've done the proportions to get from here to here. So this would just equal 1/3, and then equating it would tell us EBF is 30. And that's how we get the area. Okay. Moving on to another problem, you guys will have a few minutes to try this. It asks, what's the area of a triangle formed by the lines y equals 5, y equals 1 plus x, and y equals 1 minus x? So try that on your own, and then please try to submit your answer in the chat once you have a try at it.
If you guys come to any problems or you guys have any questions, just feel free to raise up your hands, or if you don't want to ask out loud, you can just type it in chat. But most likely, if you have a question, someone else probably has that same question. So just let us know. We'll be happy to help.
Okay, I got an answer in the chat. So Kevin said that it was 16, which is correct, and I'll be walking through how to solve that. So first, we're given the lines. So if we think about it as like a graph, oh, oops, my bad. If we think about it as a graph, we can graph y equals 5 first, as it's just a straight line. So this is our graph. And there are lines, so y equals 5 could be somewhere up here. And then y equals 1 plus x, and then y equals 1 minus x. If you look in the key observations, we say how when x is 0, y would be 1 on both sides anyway. So that tells us they would both cross a point somewhere here. So we can draw those lines. And if you just rewrite the equations, you'll see how it's just a negative slope for one of them. And then from there, if you just follow that path, when you reach y equals 5 or plug it into the equation, you would see your points. So here, we already know this would be 0, 1. And then up here would be 4, 5. And on the other side, it would be negative 4, 5, and 5. There we go. So those are the points we see. And then from there, you just have to calculate the length. So here to here, 4 and then 4 from the middle. So that would be 8. And then remember for triangles, we'll need like the altitude. So from 5 to 1, that would be 4. And then multiply that, 32. And because it's a triangle, half it, and you would get 16. Okay, great job, Kevin. Okay. Okay, next problem. This one's a little hard. If you guys want to try setting it up with me while I do it, and then from there, try to get some of the angles, and then we can go over the full problem. So the first setup would be the equal angular hexagon. And then from there, the lines basically extend. First, let's write in our letters. D, E, and F. And then the lines from there extend to create triangles. Basically like that. And then on the other side, the same as well. Good luck. And then from there, try to add in the angles that you know. I'll give you guys like 2 minutes for that. And then from then, I'll start solving the problem. Okay, we'll go into the angles. So from here, based on what we learned before or reviewed for some of y'all, the equal angle hexagon, we can find the angles for that because of the angles all being equal. We know it would be like a perfect hexagon. And like we learned before, the n-gon, the way to get the angles would be n minus 2 times 180. So because it's a hexagon, 6 minus 2, 4. And then 4 times 180 would get you 720. So let's write that down. 4 times 180 get you 720. And then from there, you can do 720 divided by 6 to get 120. So each of these angles would be 120. I'm just going to write it in for one of them. Do 2 so you can see. But know that it's for all the angles. For that. And then from there, because of them being supplementary angles, you would know that the triangle angles would be 60. So here, this would all be 60. Now, we're told that these triangles, so this one here, the blue one, would be equal to 192 root 3. So the blue triangle is 192 root 3. And then we can just set that equal to the equation. 4 divided by 2 because it's an equilateral triangle. So here, if you just solve it out, you can cancel out like the root 3 and just get pi over 2 equals 4 times 192. So once you do the math, 4 would get you s equals 16 root 3. So you do the same for the green. 3 24 root 3, and then equate it to the same. Root 3 over 4 equals side squared. And then get that down to side squared equals 4 times 324. B side equals 36. So that's almost our answer. But from here, it asks M, N, and P, the perimeter. So because we have these numbers so far, we can actually add them because it asks for, or let me draw that out. So think about this as A, B, C, D, E, and F. Because of the triangles being the same, you could just put those letters out like that. And then from there, to get the perimeter, you would basically need A plus B plus C plus D plus E plus F. That's what you're looking for, the lowercase letters. Be erasing this work. Set up for a second longer so you can see how that moves on. So from when we get these two, 36 is basically equal to just A plus B plus C. Well, this is D plus E plus F if you look on the graph or on the drawing. So from here, if you just add those together, you would get 36 plus 16 root 3. And that's what we have right here. And then you would just add those numbers itself. So 36 plus 16 plus 3, which would get you 55, which if you've seen in the chat, Kevin has sent was C. So that's correct. It'd be 55. So this is why it's important to see how the angles expand and how even if you find just one angle, you're able to find them all. And that would be angle chasing. Okay, let me delete that work. Okay, so we're going to be moving on to the Pythagorean theorem, which is probably just review for most of y'all. So just going again, Pythagorean triples. So I mentioned before when I was talking about how the sides had to be bigger, but these are some key ones to remember as they're used a lot in contest math to quickly find it as like a shortcut. So any multiple of these numbers would also work to be a triangle. For the distance formula, um, it's used for like basically the Pythagorean theorem on a graph. So when you're given 2 points to find the distance between them, you would take the x's and subtract them and then square it. And then add that to the subtraction of the y and then square that. And then if you find the square root of that, it would get you the distance. It's basically a squared plus b squared plus c squared. Next, for a 3D diagonal, there's actually a lot of problems that include 3D diagonals. And from here, a shortcut for this, instead of just solving it by finding the Pythagorean theorem every single time, it would be length squared plus width squared plus height squared, and then square root that to get the diagonal. Okay, Zoya will be taking over this question. First, you'll just get some time to go over it on yourself and try to solve it.
Okay, so the question was a rectangular box has dimensions of 3 by 4 by 12. A spider starts at one corner and walks along the surface, not through the air, to the diagonally opposite corner. So what is the shortest possible distance the spider can travel? So, um, we start with the spider like staying on the surface. So the shortest path is not through the box. So we can make this easier to see by unwrapping the box in a way. So we combine like two of the sides and then keep the third as the other dimension. So the possible combinations we can have are so 3 plus 4 squared and then plus I'm sorry, my drawing isn't really working, but um, like we're going to do like combine the different dimensions. So our first combination would be like 3 plus 4, and then 12 as the third one, and then 3 plus 12, and then 4 as the third one, and then 4 plus 12, and then 3 as the third one. So then we can use the Pythagorean theorem to find the diagonal. So once you plug in these numbers into the Pythagorean theorem, you should get like the square root of 193 as your shortest diagonal.
Okay, great. So with the messages I got sent, Kevin got square root of 193. So that's really good. Great job trying though, guys. Okay, moving on to the next. So just reviewing area. Shaded region problems also come up a lot. And so it usually just gives you a shape overlapping another shape. And then it gives you like the unwanted area and the area that's shaded that it wants you to find. And the key for this is to break complex shapes into pieces you know, so just squares, triangles, and it's a lot of just subtracting the shapes. Then moving on to area ratios. Like I mentioned before with the 3, 4, 5 or similar triangles, this comes back to area ratios with triangles that share a base. Their areas would be proportional to heights, and then triangles that share a height, their areas would be proportional to their bases. It's all just the ratios. Okay, you guys have a few minutes to complete this problem. Okay, I got a few answers. So yeah, do you want to start explaining while I draw?
Okay, so the question was a square with the side length 10 has a circle inscribed inside of it, which is tangent to all four sides. Inside the circle, a square is inscribed all four vertices on the circle. So what is the area of the region inside the outer square but outside the inner square, excluding the circle? So you're gonna solve this by starting with the outer square. So its area is 10 squared, so 100. So the circle is inscribed inside the outer square. So its radius is half the side length. So the radius is equal to 5. So we can plug this into the area formula for the circle, which gives us 25 pi. So for the inner square, since it's inside the circle, its diagonal equals the diameter of the circle, which is 10. So using the Pythagorean theorem, its side length is 5 root 2, so its area is 50. So we want the region inside the big square but outside the inner square, excluding the circle. So we can subtract the circle and the inner square. And then once you simplify, you should get your final answer as 100 minus 25 pi.
Great job. Okay, we'll move on to the next problem then. So here's just where the solution is, if you guys want to come back to this. Okay, you guys will have a few minutes for this as well.
Okay, so the question was a square with the side length 2 and a circle share the same center. The total area of the regions that are inside the circle but outside the square equals the total area of the regions that are outside the circle but inside the square. What is the radius of the circle? So for this question, we can see that since the areas of the regions outside the circle and the square are equal to each other, the area of the circle must be equal to the area of the square. So since the side length of the square is 2, we know that the area of the square is 4. So since the area of the square and circle are equal to each other, we can set pi r squared, which is the area formula, to 4 and solve for the radius. So we end up getting radius is equal to 2 over square root of pi.
Okay.
Okay, so now I'll be going over a volume and surface area. So I'm pretty sure you guys have seen these formulas before. So instead of going over each one, I'm just gonna go over like the base concept. So if you're thinking about volume of, if you're thinking of volume of a shape, what you want to think about is multiplying the base by the area. So let's just say you had a prism, like a cube or something. You'd want to think about the base of a cube and then how much height it provides. That's the volume of something. So the 3D filling of something. So in that case, you would find the base of the square, which is just all the same side, and then you would have the height, which is also the same side. That's why it's just cubed. So similar to surface area, if you wanted to do the same cube, you would realize, so surface area is like the outside. It's like the wrapping of a solid. You would want to find the total of all the sides, the total surface of all the sides. So you would just do each side squared, and then you would have that 6 times. So one of the most common shapes you have are prisms, cylinders, cones, spheres, and rectangular prisms. So yeah. So now I'll be going over a contest geometry question. So a solid is taking a line segment and considering all the points in space that are within 3 units of that segment. This creates a shape like a cylinder with two hemicircular ends. So a hemisphere is just two half so two half spheres. So that's a hemisphere. Hemisphere is half of a sphere, and each hemisphere is having a radius of 3. If the total volume of the solid is 216 pi, what is the length of the line segment? So if you can see, we're gonna find that length of the line segment. And yeah, so I'll give you some time to solve this question. This one's a bit hard. And this will be our last contest question too. So just hang in there. Oh, and also just in case you don't know, the volume of a sphere is 4 over 3 pi r cubed. That's the volume of a sphere. Yeah, I'm pretty sure you guys know the area of a circle. Or once you have the answer, just type it to me in chat and I can check. Sorry, I was muted. So I see some answers rolling in chat, so I'm gonna take up this question. So the component of this solid essentially, which I guess some of you guys realized, was it's just a cylinder. I mean, it's hard to do some 3D drawings, but I'll try. And then you have two spheres, hemispheres at the end. Like, okay, I know it's a pretty bad excuse for my bad drawing. So if you look at the cylinder component, what a cylinder is you have two circles, like a base as a circle, and then you have the height. And that's the height that you're solving for. So when it says the length of the line segment, that is what we're solving for. So if we do the volume of anything is just the base times height, the base is a circle, which is pi r squared, times what we want to solve, which is the height. So for the volume, we can just say that because it's 3 radius and it's radius squared, we can say that 9 pi times the height, which is what we're solving for, plus two hemispheres. So if you have half a sphere, so if the volume of a sphere is 4 over 3 pi r cubed, half of the sphere is going to be half of this. But because you have two of them, two halves makes one whole. So at the end of the day, you also just use this formula normally because two halves of a hemisphere just makes one sphere, which is what we're trying to find for. And you could have 4 over 3 pi and then 3 cubed. And all of this equals to a total volume of 216 pi. So if you did the math and you isolated because time's running out, sort of, you would come to the conclusion that the height equals to 20 units. So that's the answer I saw a few people give. So good job. Okay. So now we're gonna try connecting geometry towards how AI sees it in the real world. So nowadays, you guys see like AI is able to take our images, able to do crazy stuff. We give an image, it's able to animate it, or you give an image, it's able to tell you about it. But how can that really do it? So how AI sees our images is it converts our faces, our colorful faces into a grayscale, and it ends up using a rating that it has. So a very dark patch, so like the hair, for example, would be like 255. Sorry, and yeah, no, it'll be 0. And something that's really light. So for example, the background would be 255. So it'll end up making outlines based off that. So you can see the original image, and then you could sort of see the outline it has. And that outline creates a little, it creates shapes. And using that shapes, it has an algorithm, which we might talk about in the future. But it'll use an algorithm to see that, okay, using this shape, I see circle, and then it sees a little more circles, or I guess ovals. So then it can detect those are the eyes. It can see the ears, and through that, it's able to realize that that's a person. So certainly, if there's something like a cow, maybe, and it'll do the grayscale, it would see the cow's shapes, and based off an algorithm. And once again, AI has so much data. So it compares in its database what a cow would look like, what a human would look like. It knows that in its database. And based off that, it would able to come to the conclusion that that's that object. Oh, yeah. And I'm going to talk about how distance formula in AI works in general. This is another concept. So finding a correlation between things. So let's just say you have data, so what this is basically is this is finding like your recommended. So if you're watching a YouTube video, you make a brand new account, you watch a YouTube video on like, I guess a specific type of gaming video. And then you refresh your YouTube tab after, you start to notice that you get several videos similar to that gaming video. And how it does that is through the distance formula, actually. How an AI is the one that's using an algorithm to give us that recommendation, but it uses a distance formula to find that. So let's just say that this is your target, okay? What it'll do is, first of all, it'll try to find a correlation between all the things. So this, you might watch a gaming thing on, I guess, like Minecraft, let's just say a game, okay? It'll give you things related to Minecraft. So if you want to see like those like IRL boxing videos of Minecraft or something like that or gaming. And based off that, it'll give us points. And this math is actually this is the distance formula between 2 points on a Cartesian plane. So if you had a Cartesian plane and you had these 2 points, you wanted to find the distance between them, you don't just do subtraction, you use this formula, x2 minus x1 squared plus y2 minus y1 squared, whole square root that, which is derived from the Pythagorean theorem. And similarly in 3D, we use z as a third dimension, and for nd, so for any dimensions, because now we have like 4D, 5D, we see all these crazy things, it'll be this formula. So the delta of it, so delta is just the change in, and that squared to the whole root. It'll use the distance formula to find what is the best match. So for example, between if you think about all of this as a Cartesian plane, and you had the distance formula, it'll check the distances between each of these things. And right now we can sort of eyeball it. We can realize that this and this are close while these ones are far. So we could outline as these as the outliers, and we can have the closer ones as the correlation through the distance formula. Similarly, if you had more factors, you wanted to bring this into third dimension, you would have the z. So it would be like this, like sort of sticking out on the screen, and then one down. And it keeps on going for nth dimensions. Okay. So yeah. So finally, just things that we've seen geometry in AI image recognition is self-driving cars. Like we see Tesla's autopilot and everything. It needs to use AI to able to detect whether you have a car in front of you, or if you have a tree, or if you see a turn signal. That means if you see those signs where it turns, you have sharp turns, etc. Facial recognition when you're opening your iPhone or you're opening your phone and you realize that it needs to see whether it's you or not. That uses AI. Medical imaging, if you're taking these CRI scans or you're taking these scans to detect tumors, it'll use AI to see whether something's malignant or not. And warehouse robotics, because nowadays everyone wants to do digital shopping since the pandemic. It's convenient. So working through that uses AI from geometry. So anyways, thank you all for staying with us. Yeah, today went a bit long workshop. We all appreciate you guys coming. We hopefully want to see you in the next workshop. We'll be going over different concepts. So if you guys could stay tuned to your email or your parents' email. If you have any questions, feel free to ask us. Otherwise, I'll see you next month. We'll see you next month.
And share the workshop with any of your friends, and have them join. Okay, thank you.